Ship 36's explosion should have destroyed Massey for months. Every expert said impossible, 3 to 4 months minimum. But SpaceX shocked the industry. 40 days later, Ship 38 is testing there. What insider secret did they use that no one saw coming? The answer will blow your mind. Let's dive right in. Here's what nobody expected to see that morning. When Ship 36's COPV tank detonated on March 15th at 3:47 a.m., the explosion registered on seismic equipment 12 miles away. The blast carved a 30-foot crater into reinforced concrete and hurled 2-ton steel fragments over 300 yards like deadly confetti. When dawn broke, engineers stared at what looked like a battlefield. The static fire stand, a 200-foot steel monument designed to contain rocket explosions, was twisted into abstract art. Fuel lines worth millions were severed clean. Electrical systems that took months to install were fried to circuit boards and melted copper. Boeing took 8 months to repair similar damage at their test facility. Blue Origin needed 6 months for far less destruction. Industry veterans immediately made the call: 3 to 4 months minimum for basic operations, maybe a full year for complete restoration. But within 6 hours of the explosion, something absolutely unprecedented happened. While every other aerospace company would spend the next month forming investigation committees and conducting environmental impact studies, SpaceX construction crews were already moving heavy equipment onto the site, not to investigate the damage, to start rebuilding immediately. This violated every standard aerospace protocol in existence. Federal regulations typically require weeks of damage assessment, root cause analysis, environmental studies, and safety reviews before any reconstruction can begin. These processes alone usually take 30 to 60 days minimum. SpaceX basically said, forget all that, and launched one of the most aggressive rebuild campaigns in rocket industry history. They had identified one priority that trumped everything else: get Massey operational before Flight 10's launch window closed forever. The timeline was absolutely brutal: 40 days maximum, or lose months of progress and potentially billions in delayed missions. But how do you rebuild a rocket facility in 40 days when the world's best engineers say it's physically impossible? The answer lies in 3 revolutionary tactics that no other space company has ever attempted at this scale. While the entire world focused on that twisted pile of metal that used to be a static fire stand, SpaceX was secretly executing something far more ambitious. They weren't just repairing Massey, they were completely reimagining what a rocket testing facility could be. The master plan involved splitting their workforce into 3 separate teams, operating simultaneously across multiple locations. Team Alpha handled debris clearing and basic infrastructure repair at Massey itself. Team Beta began constructing entirely new systems off-site at the Star Factory using advanced manufacturing techniques. Team Charlie started modifying existing equipment at Pad A to create backup capabilities that could integrate with the new Massey design. This parallel approach meant multiple massive construction projects happening at once, instead of the traditional sequential method. Every other aerospace company does one thing at a time for safety and quality control reasons. SpaceX was doing everything simultaneously, accepting massive coordination challenges in exchange for impossible speed. The tank farm, those gigantic fuel storage containers that hold thousands of tons of liquid methane and oxygen, had miraculously survived the blast with minimal damage. Only one tank showed scorch marks from the flames, proving how well these volatile fuel systems were engineered and reinforced. This was the crucial lucky break they needed. Without fuel storage damage, they could focus 100% of their resources on revolutionary testing infrastructure instead of rebuilding basic systems. But the real genius move was what they decided not to rebuild. Instead of reconstructing the destroyed $50 million permanent static fire stand, SpaceX made a decision so radical it sent shockwaves through the aerospace industry. They would eliminate massive permanent structures entirely and pioneer a completely modular testing approach. Traditional rocket testing has always required enormous permanent monuments, essentially steel skyscrapers, built to contain and channel rocket engine explosions. These structures take 6 to 8 months to construct, cost tens of millions of dollars, and represent single points of catastrophic failure. SpaceX's breakthrough innovation, modular transport, stands that could position rockets for testing while remaining completely replaceable. If something exploded and destroyed the platform, you'd lose a replaceable component worth hundreds of thousands instead of an irreplaceable facility worth tens of millions. This decision immediately cut potential construction time by 75%, but it also introduced completely new risks that had never been tested at this scale. Would modular platforms be stable enough for cryogenic testing involving thousands of tons of supercooled propellants? Could they handle the extreme vibrational forces of rocket engines without catastrophic resonance? Would the precision be sufficient for the microscopic measurements required? The engineering team had exactly 25 days to design, build, test, and prove this revolutionary system worked, or watch their 40-day deadline crumble. By day 20, serious doubts were creeping into even SpaceX's notoriously optimistic engineering culture. The modular system was struggling during initial stress tests. Vibration levels were measuring significantly higher than acceptable parameters. Temperature sensors throughout the platform were giving inconsistent readings that could indicate structural problems. Some senior engineers were quietly suggesting they should abandon the 40-day target and return to traditional reconstruction methods. That's when Elon Musk made a decision that shocked even SpaceX veterans who thought they'd seen everything. Instead of slowing down to address the problems, he ordered them to accelerate with double parallel tracks, continue developing and refining the modular system while simultaneously preparing Ship 38 for testing using the existing infrastructure at Pad A. This meant double the workforce, double the resource allocation, double the coordination complexity, and double the risk of spectacular failure. But it also created a crucial backup plan if the revolutionary Massey approach wasn't ready in time. The pressure was incredible. Teams were working 18-hour shifts, sleeping in temporary trailers on site, and pushing manufacturing capabilities to absolute limits. Then on day 30, something completely unexpected happened that changed everything. Ship 38 rolled out of Mega Bay 2 at exactly 2:07 a.m. on July 27th under cover of darkness. Based on all internal schedules and public expectations, everyone assumed it would head toward Pad A for traditional static fire preparations using proven infrastructure. Instead, the massive vehicle made a sharp turn toward Massey. This wasn't in any official plan. According to every internal timeline that had been shared, Massey wasn't supposed to be ready for operational testing for at least another week, possibly 2. Something fundamental had changed overnight. The modular system hadn't just worked during final testing, it had exceeded every single performance expectation by significant margins. Vibration levels that had been problematically high just days earlier were now measuring lower than the original permanent static fire stand. The platform was more stable, more precise, and infinitely more maintainable than anything they'd built before. SpaceX had accidentally created a superior testing facility while trying to rebuild quickly. But there was more happening than anyone realized. Here's the part of this story that SpaceX doesn't want their competitors to fully understand. While rebuilding Massey's physical infrastructure, they were simultaneously installing one of the most advanced sensor networks ever deployed at a rocket facility. We're not talking about basic monitoring equipment that measures obvious things like temperature and pressure. This was thousands of microsensors throughout every surface, measuring everything from microscopic concrete stress patterns to atmospheric pressure fluctuations to electromagnetic field variations that could indicate equipment problems before they become visible. This sensor network meant they could detect potential problems in real time and predict failures before they happened, instead of discovering issues during catastrophic test failures like traditional facilities. Most rocket testing sites wait for something to break before they know there was a problem. The new Massey can predict component failures hours or even days in advance. The Ship 36 explosion wasn't just a setback that cost them time and money. It had accidentally become the catalyst for creating the most technologically advanced rocket testing facility on Earth. While Ship 38 was positioned for cryogenic testing, SpaceX quietly conducted another test that revealed the true scope of their achievement. They opened and tested the PEZ door, the satellite deployment hatch used for Starlink payload missions, while the vehicle was fully loaded with thousands of tons of cryogenic propellants. This wasn't just a random additional test. It was proof that the new Massey facility could handle multiple complex operations simultaneously with precision that exceeded their original permanent infrastructure. At 9 a.m., workers were actually climbing into Ship 38's payload bay for technical inspections while massive cranes operated around the prototype, and fuel loading operations continued. The facility had evolved from a single-purpose static fire stand into a multifunction testing complex capable of operations that were previously impossible. Those futuristic-looking adapter ports being developed for Ship 37 weren't just aesthetic improvements. They represented SpaceX's revolutionary new quick disconnect system that can transfer propellants faster and more safely than any previous technology. This system, perfected during the urgent Massey rebuild timeline, will be retrofitted throughout their facilities to create testing capabilities more advanced than anything NASA has ever built. What does this 40-day rebuild actually mean for the future of space exploration? SpaceX just proved that rocket facilities don't need to be permanent monuments that take years to build and can never be moved. Infrastructure can be modular, rapidly deployable, and relocated anywhere in the world within weeks instead of years. The implications are staggering when you think about them. Mars colonization missions could use identical modular systems for testing and maintaining rockets on another planet. Military space operations could deploy complete rocket facilities anywhere on Earth within a month. Commercial space companies could rent advanced testing capabilities instead of spending billions building permanent infrastructure. Private space companies that currently can't afford their own testing facilities could access world-class capabilities through SpaceX's modular approach. Countries wanting to develop space programs could have operational rocket testing within months instead of decades. The Massey rebuild has quietly revolutionized how humanity thinks about space infrastructure forever. But not everyone in the aerospace industry is celebrating this achievement. Behind closed doors, serious questions are being raised about SpaceX's methods that could have major implications. NASA officials have remained conspicuously silent about SpaceX's approach to the rebuild. Privately, multiple sources have expressed significant concerns about rushing critical safety systems without following established protocols that exist for very good reasons. Some veteran engineers are worried that this sets a dangerous precedent where speed is prioritized over methodical safety verification. What happens when other companies try to replicate these methods without SpaceX's unique engineering capabilities and risk tolerance? Did SpaceX actually cut important safety corners to meet their 40-day deadline? Are modular systems truly as reliable as permanent structures under extreme conditions? Can this approach be safely scaled to other companies and applications? Industry insiders are asking hard questions, but they can't argue with the results. Ship 38's successful cryogenic testing proved the rebuilt Massey works exactly as designed. The real test is still coming. Here's what's really at stake with this entire achievement. The 40-day Massey rebuild wasn't just about getting one facility operational quickly. It was preparation for something much bigger that most people don't realize. Block 3 Starships are coming later this year with capabilities that will require even more advanced testing infrastructure than anything that currently exists. These next-generation vehicles will be larger, more powerful, and more complex than any rocket ever built. The Massey rebuild was essentially a proof-of-concept demonstration for rapid space infrastructure deployment anywhere it's needed. If this approach is successful long-term, SpaceX could theoretically build complete rocket testing and launch facilities on Mars using identical modular principles. But first, they need to prove that rebuilt Massey can handle the ultimate stress test. Ship 38's full static fire test with all 6 Raptor engines at maximum power. This test is scheduled for the next few days, and the entire aerospace industry will be watching every detail. The 40-day miracle that shocked everyone faces its ultimate challenge. Will SpaceX's revolutionary modular approach hold up under the extreme conditions of actual rocket engine testing? Will their speed over traditional safety philosophy prove justified, or will it finally catch up with them in a spectacular failure? The answer will determine whether this becomes the new standard for space infrastructure development worldwide, or a cautionary tale about the dangers of moving too fast in rocket science. Either way, SpaceX has already changed the conversation about what's possible forever. So here's what we just witnessed. In 40 days, SpaceX didn't just rebuild a facility, they rewrote the rules of aerospace engineering, While traditional companies measure progress in years, SpaceX measures it in weeks. But this story raises a bigger question that goes way beyond rockets. Are we watching the birth of a completely new approach to solving impossible problems? One where speed and innovation matter more than following established rules? The Massey rebuild proves that when you're willing to throw out the playbook and think differently, you can achieve things that everyone says are impossible. But it also shows the risks of moving fast and breaking things when those things involve rockets that could explode. What happens when other industries start adopting SpaceX's methods? What happens when other countries realize they don't need decades to build space capabilities? The 40-day miracle is just the beginning of something much bigger. And honestly, we have no idea where this leads. What do you think? Is SpaceX's approach the future of engineering, or are they moving too fast for their own good? Let me know in the comments because this conversation is just getting started. SpaceX engineers are panicking. A NASA scientist just revealed a Mars rocket that makes Starship look like a joke. Dr. Zubrin's mini Starship needs only 120 tons of fuel. That's 5 times less than Musk's 600-ton monster. Here's what terrifies Elon. This tiny rocket could reach Mars first and cheaper. Is this the end of Starship? Let's dive right in. Three months ago, behind closed doors at NASA headquarters, something unprecedented happened. Dr. Robert Zubrin walked into a room full of SpaceX's biggest supporters and dropped a bombshell that left everyone speechless. The presentation lasted exactly 47 minutes. By the end, half the room was questioning everything they knew about Mars exploration. What did Zubrin show them? A single slide with 2 numbers, 120 versus 600. Those weren't just statistics. They were the beginning of space's worst nightmare. Here's what's keeping Musk up at night. While SpaceX burns through $3 billion developing Starship, Zubrin created something that makes their giant rocket look like an expensive mistake. His mini Starship needs only 120 tons of fuel to leave Mars. Starship? A whopping 600 tons. But that's just the beginning. The real killer is what this means for mission timelines. SpaceX estimates 8 to 10 refueling flights just to get one Starship to Mars. That's potentially $800 million per mission,